In this video, this unit, we're going to look at different types of inequalities to solve. So we've been solving some equations throughout the semester, and now we're going to look at inequalities. Okay, so we have absolute value inequalities. So we could have in these four different scenarios, if it's linear inside, which is what we're going to look like. So let's just jump to an example. This is my linear inequality that I have to serve absolute value. Okay. So let's start with the explanation and how I like to talk about absolute value as distance from zero. Okay, so let's do a real basic one to start before we do 1 and 2. And I'll say less than 2. Okay, so if the absolute value of x is less than 2, that means its distance from 0 is 2. If I looked at a number line, that means I could be as far as 2 away. Or I could be back here, right? Anything in this, there's 1, there's 2. Any number in here is a solution to this inequality, okay? So what we want to do is, when we solve these, we can rewrite it without the inequalities. That allows us to do some algebra. So what's the equivalent set here? It's x between -2 and 2. Okay, so this is the process we're going to use with this one. If I have a more complicated expression in here, I'm going to approach it the same way. Now, if this were less than or equal to, then I'd have to include the endpoint, so I would use a bracket. Okay, but the process would be the same. Now, what if it's the distance from 0 would be greater than 2? Well, that would just be all the values out here on the number line, right? Further away from 2 in both directions. So how would I represent that set, or those two sets, as an inequality? Well, you could be less than -2, or you could be greater than +2. Greater than +2, greater than or equal to in this case, if I include the bar. If I include the equal to bar, then we're going back that direction. Okay? So let's apply that to these problems. So if I have a less than inequality, I put whatever in my inequality bars and I wedge it between the negative and the positive, and then this is how I would solve it. Subtract, in this case, subtract 2. Just do your typical algebra process in order to solve this equation. And that's it. In interval notation, that goes from -6 to 2, and because it's not equal to, we would use parentheses. All right, let's see if we can do that for the next one. It's a greater than, so I set up one inequality right away. Just drop the absolute value bars. It's greater than the +5. And the other scenario, it's going the other direction. That means it's less than or equal to the -5. Okay, on the number line, if you had to graph that, there's 0, here's 6, here's -6. It's all these values out here, shaded, going that way. And all these values out here. Anything out here is a solution to that inequality. Take a minute to read this scenario, and then let's see if we can write it. Well, if we want the degrees to be between 45 and 55, that would look like this. And then it says inclusive, so I would include that. But the directions asked to write this as an absolute value inequality. We're within 5 degrees of 50, so I would write it like this. Okay, so the translation here would be this is within 5 degrees of 50 degrees. And another way to think about it, if the next step would be to write like that, like we did before to solve. So this would be my answer to write an absolute value inequality for this scenario. All right, moving on to polynomial and rationals. The big deal with these ones is we're going to find the zeros. Okay, if I give you a polynomial function, just look at this example. It doesn't matter what it is. I want to know, let's just call it f. If I want to know when f is, let's say, less than 0, if I'm looking at its graph, less than 0 means under the x-axis, negative y values. And I think my answer would be right here. Right? If I have the graph, I can just look at the graph and say, okay, it's from 0 to 4. All right, so that would be my solution if I have the graph. But the process, we're going to do some test points. So if you think about it, if I don't have the graph, I can find the zeros. We know how to do that. If there's 3 zeros, then there'll be 4 intervals that I need to test, right? Because at the x-intercepts, it either bounces or crosses through. So it could go from positive to negative at an x-intercept. It doesn't on this one, but it does on this one, from positive to negative. So what I do is I break up my real number line at the zeros, or x-intercepts, and then I just plug a test point in. Like let's say I chose -5 for this entire interval, which is negative infinity up to -3. Then I can pick any point I want, -4, -6, and I should get the same output. Not the same number output, but the same sign, positive or negative. And the reason I'm doing that is because I want to figure out when it's negative. Okay, let's see what that looks like in practice. All right, so I have this problem. So how do I find the zeros? Well, we know how to do that. We factor. X squared plus 7x. So I'm going to factor out the x. I want to know when that's less than 0. Then I'm going to factor this. Two numbers are multiplied together to give me 30 negative, and add together to give me 7. Should be 10 and 3. And then I can see what the zeros are. There's one at 0, there's one at -10, and there's one at 3. So I'm going to break up my real number line. You could do this by graphing. We could probably graph that pretty easily. But let's do it by this critical number approach. 0 is a critical, is an x-intercept. 0, -10, and 3. Okay? So what I'm going to do is test points. Remember, it has to do. So my intervals would be negative infinity to -10, and then -10 to 0, and then 0 to 3, and then 3 to infinity. Okay, so I do a test point from each one, and I see what output I get there. So that is if I plug in something back here, I think it'd have to be f of -11. Or -12 or -13, anything you want, -100, and I plug it into this function right here, my graph, my factored form. So f prime of -11, I don't really care what that is. It's a negative value times -11 plus 10 is negative. -11 minus 14. I'm just plugging it into my factored form, and it's the product of 3 things. 1, 2, 3. Everything's negative when I plug in a -11, which means my result here is a negative number, right? That's positive. Positive times a negative is a negative. So that's negative, or it's less than, negative and less than 0 mean the same thing. So it's less than 0. So that interval is going to be part of my solution. So we have to check the other ones. -10. Plug it in -10. You get f of, I'm sorry, -9 would be in this interval, or -5, or -1 would be the easiest one. Let's plug in -1. I get a negative here. I get a positive for that one. That'd be 9. Don't care that it's 9, just care that it's positive. And I get a negative for that one. So it looks like it crosses the x-axis at -10 because this goes to positive. Won't be part of my solution set. Keep going. F of 1. Positive, positive, negative means it's negative in the end, or less than 0. Part of my solution set. 4. Positive, positive, positive. F of 4 is positive. Okay, so my solution set is where I got negative results. So it's these two intervals. The answer to the question is from -infinity to -10, my function's negative. And then from 0 to 3, my function's negative. If there was a bar under here, I'd use brackets so I can include the endpoints. And if it was, think about if that was a greater than inequality, if that's a greater than, then it would be the positive result. So this and this would be my solution.